Unit 2.2, defining the derivative. This derivative is an expression that calculates the instantaneous rate of change, or slope of the tangent line, of a function at any given x value. In other words, it gives us the slope of the function at a point. So this is the function of x, squared. F prime of x is 2x. F prime of 1 is 2. F prime of 2 is 4. And if prime of -2 is -4, we know this because since this is the derivative of the function already, all we have to do is plug in the x values and get the y values. If f prime of x equals 5/x minus x, find f prime of 2 and explain the meaning. So since this is the prime function, we plug in 2 into x. So this becomes 5/2 minus 2 equals 1/2. And the explanation, the slope of the tangent line of f of x at x equals 2 is 1/2. If f of x represents how many meters you have run and x represents the minutes, describe in full sentences the following. F of 8 equals 1500. So we can explain this as after 8 minutes, I ran 1500 meters. F prime of 3 equals 161. And this can be explained as at the 3rd minute, I was running 161 meters. Notation for the derivative. Lagrange is f prime of x, or simply y prime. And Leibniz is dy over dx. Definition of the derivative. This limit gives an expression that calculates the instantaneous rate of change, or slope of the tangent line, of f of x at any given value. So the definition of the derivative is f prime of x equals the limit as theta x approaches 0 of f of x plus theta x minus f of x over theta x. Find the derivative using the definition of the derivative. So right here we can find that we plug this into the equation. So f prime of x equals limit. Instead of theta x, we'll be using h. It's the same thing. So 2x plus h squared minus 7x plus h plus 1 minus 2x squared minus 7x plus 1. Ran out of room a little bit. This is all over h. And we can combine like terms and cancel stuff out. And this will all become 2x squared plus 2hx plus h squared minus 7x minus 7h plus 1 minus 2x squared plus 7x minus 1. We can cancel out the 1, the 7, the 7x. So all over h. And that'll equal 2x squared plus 4hx plus 2h squared minus 7h minus 2x squared. H. You can cancel out these 2's, and that'll equal 2h squared plus 4hx minus 7n over h. You can factor out the h's, and this will be h. 2h plus 4x minus 7 over h. You could cancel these h's. And then the limit as h approaches 0 equals, since you could plug in 0 for the h's right here, that takes out this. So this is just 4x minus 7. Y equals 1 over x squared. Dy dx, this is derivative of limit x approaches 0. 1 over x plus h squared minus 1 over x squared over h. And this just equals, ooh, we're running out of room. X squared over x squared, x minus h squared minus x minus h squared over x squared, x minus h, because you want to make the denominators the same. That can become x squared minus x squared plus 2h x plus h squared over x squared x plus h squared, and you multiply this by 1 over h, and this will equal to negative 2hx minus h squared over x squared x plus h squared. You multiply it by 1 over h. This will become, to factor out the h's, 2x minus h over x squared x plus h squared multiplied by 1 over h, and you finally can cancel out those h's, and then this will just become 1, which is like nothing, it stays the same. And then this will equal negative 2x minus h over x squared multiplied by x plus h squared. You plug in, you make h approach 0, so it's negative 2x minus 0 over x squared x plus 0 squared, and this will become negative 2x over x to the power of 4, and then we cancel out the x's on the top and the bottom, so the derivative equals negative 2 over x cubed. Equation of the tangent line. The tangent line to the curve of f of x at x equals a can be represented in point slope form. Y minus y1 equals m multiplied by x minus x1. And this is basically, this is y minus f of a equals f prime of a multiplied by x minus a. That's just another way of writing it. If we know h of 5 equals negative 2, and the derivative of h is given by h prime of x equals x cubed minus 2 over x, write an equation for the line tangent to the graph of h at x minus 5. 8x equals 5. So, since we know, we already have the derivative of h right here, we can just plug in 5 for the x's. So this becomes, so h prime of 5 equals 5 cubed minus 2 over 5, which equals 123 over 5. So this is the slope, as we can see right here, f prime of a. This is the slope. Then we're already given the x and the y values, so we could just plug into this equation right here. Y minus negative 2 equals the slope 123 over 5 multiplied by x minus 5. That's the equation. Number 6, the graph of f prime of x, the derivative of f is shown at the right. If f of 2, sorry about that. The graph of f prime of x, the derivative of f is shown at the right. If f of 2 equals 7, write an equation of the line tangent to the graph of f at 2, 7. We have the equation right here. So we have they give us the x the y value. So all we have to do is find the slope. And the graph is already this is the derivative. The derivative of f. The graph represents the derivative of f. So all we have to do is find what the value, what the derivative, what the value, what I'm sorry, the value of the derivative at f of 2. So x equals 2, 1, 2, 3. So f prime of 2 is 3. And that's the slope. So if you just say y minus 7 equals 3, x minus 2.